Okay, well, good morning, everyone. Hello, and welcome to the Bow Valley Sustainable Building Summit. My name is Jody Cornwell, and I'm a program coordinator at the Biosphere Institute of the Bow Valley, and I'll be your host today. Before we get started, I just wanted to go over a few housekeeping notices. Firstly, as webinar attendees, you will not be able to unmute your microphone without permission or turn on your video. However, we do welcome active participation at these events. So if you have any questions for Dale as he moves through his presentation, please do type them into the Q&A box, which is accessible using the bar along the bottom of your screen. Dale will be answering questions as they come in, and there should be room for a little bit of additional Q&A at the end of the presentation if you have further questions. If anyone is experiencing any technical difficulties, please do reach out to me privately in the chat function, and I'll do my best to assist you. So the Bow Valley Sustainable Building Summit has been brought to you, as always, by the Biosphere Institute of the Bow Valley and the Bow Valley Builders and Developers Association. The Biosphere Institute is a local Canmore-based charity, and we aim to address what we believe are the two major challenges affecting the Bow Valley today, one of which is human-wildlife coexistence, and the other is climate change. Our climate action efforts are managed under the Bow Valley Shift program, where we promote local action, empowering Bow Valley residents and businesses to reduce their energy emissions, waste, and water use. The Bow Valley Builders and Developers Association is a membership-driven networking and advocacy group. BODA keeps its members up to date on issues impacting the industry and our community. BODA luncheons, pre-COVID of course, have become the premier monthly business networking event in the Bow Valley. And a little bit of good news, they were able to start doing their luncheons again as of September. So if you're not already a BODA member and you want to join in, please do sign up. So with funding from Energy Efficiency Alberta and the town of Canmore, which we are incredibly grateful for, the Biosphere Institute spent 6 months in 2019 talking to local businesses. We really wanted to learn what they knew about energy efficiency and also what else they wanted to know. The result is the Bow Valley Sustainable Building Summit, and due to COVID-19 pandemic, we made the decision to cancel the original in-person event and take our learning online. So without further ado, I'd like to now introduce today's presenter. We have back in the hot seat, Dale Mikkelsen, our original keynote presenter. Dale is the Vice President of Development for the SFU Community Trust. Dale and the Trust team are making significant and innovative contributions towards the creation of independent and universal green building standards to ensure a high level of urban design and environmental performance. Dale is charged with raising the bar of sustainable community planning to ensure UniverCity remains on the leading edge of energy efficiency, material conservation, healthy environments, and community building. We're really excited to hear about some of your projects, so over to you, Dale.
Okay, I will try to share this screen here. Just let me know if it's up.
Yep, you're good. Thanks, Dale.
Okay, great. Oh, and I'm going to open up the comment section here so I can see if there's any Q&A coming in. All right, perfect. All right, well, thank you for this, and I'll just do a little time check here so I don't bring any of you over time. So previously I spoke about the community of UniverCity, which is what we call a model sustainable community, sort of a greenfield development adjacent to Simon Fraser University in Burnaby, British Columbia. Burnaby is a near suburb to Vancouver, BC proper. It's a university of about 27,000 full-time equivalent students, and the community itself that's being developed on lands that are considered residual to the university core academic needs will ultimately be between 8,000 and 10,000 people upon full development. At this point, we've got about 6,500 residents living in the community, and it's a comprehensive community. So when we say model sustainable community, we're not talking just about environmentally friendly buildings or environmental performance, but we're also talking about equitable communities. So we built and continue to build affordable housing for purchase and for rental. We have regular market developments done by market developers where we lease them land on 99-year pre-hold leases, and they market and sell strata condo, strata townhouse homes to regular folks. We also talk about the economy. So one of our objectives, of course, is to make money. All of our earnings and proceeds should be at a regular developer's profit. And all of that money goes back to the university in an endowment fund for teaching and research. So other than where our money is distributed, our economics should look like that of a traditional developer. And then our fourth component is education, where we're teaching, striving to teach people about how to build these more environmentally friendly communities. So one of the things I spoke to but didn't go into detail on in my last presentation was the fact that we do have mandatory green building requirements in our community for all of our developers, and those have been worked through closely with the local development community and are a combination of performance and prescriptive standards. Ultimately, any developer in our community that wishes to pursue their own independent certification typically use systems like the LEED certification system and achieve generally LEED Gold on their buildings. So we have confidence that our green building requirements that are bylaw based, meaning the City of Burnaby helps enforce those requirements under the Standard Municipalities Act. So it is something that's replicable elsewhere. Are achievable at near conventional building costs. We see our developers producing these buildings now that they've been doing it for the last 10 years up on the community at 0 to less than 1% cost increment. And we help facilitate that with our, as I spoke to last time, our neighborhood energy utility, our neighborhood stormwater management systems. So they're seeing fairly conventional service connections that are going to sustainable features. That help them, for example, increase their energy efficiency, be able to use in their modeling higher efficiency numbers than they would with an in-house boiler, et cetera, et cetera. But one of the things that we've made a point of doing is whenever we develop the community facilities, as any master developer does and is typically required as part of a negotiation with the city, we ensure that our facilities are built to a quote unquote greener standard than we're asking our developers. That way, A, we can pilot technologies that they may be nervous to try that we want to try. B, we can demonstrate that we're not just asking of them, but we're also performing on our own account. And C, it's part of that model, right, and the connection to the university. So these are usually done in partnership with learning at university departments at Simon Fraser University. So they're embedded in curriculum and classroom development. So two of the buildings I'll speak to today, one comprehensively and one from a more cursory level, is the university childcare facility, which you're seeing here. And then another one that is only currently known as Parcel 21 as it's under construction and hasn't gone through a naming process. So the university childcare facility was one of Canada's first attempts at meeting a building performance system called the Living Building Challenge, which I'll go into shortly. And then Parcel 21, very different than this, is an affordable rental project, really targeting graduate students with children to move those graduate students with children out of the quote unquote res precinct of the university and into the community precinct of the university. So these folks with children that are going to be at the university for 2 to 3 years have access to things like childcare, have access to the grocery store, have great access to transit, et cetera, et cetera. So that's the two projects I'll speak to, and we'll start with the childcare. Oh, it didn't move forward. We'll try again. There we go. So I've talked about the community. Here's just an overview of some of the community in terms of the aerial photo. The team for this project was HCMA Architects, so a local architectural firm here in Vancouver. Fastenamp was our structural engineer, very familiar with high performance building structure and volumes. Cobalt Engineering, who are now, the name has escaped me, but anyways, they've merged with a larger partnership, but again, familiar with sophisticated and simple low carbon mechanical systems. MMM was our electrical, Space to Place is sort of our community landscape architect and one of our favorite groups, and Lead Core Special Project Services was our contractor, because they were seeking experience in these alternative building types. So really the building started with a vision. Photos you see are from the building. It's now been in operation for just a little over 4 years now. So the notion was that the project brings together the renowned Reggio Emilia childcare model with building that promises to raise the bar to a new level of environmental stewardship. That Reggio Emilia childcare model is really a model where the student is the teacher is the student, and it's complete immersion. So it relies on a playful infrastructure and open infrastructure. So not your typical managed daycare facility where you have group A or group B, but it's really about immersing the students, the teacher, and the environment also as an educator. So it fit really well with the living building model. And it's certainly a model of childcare delivery that's being promoted heavily in North America. And further to that, the Simon Fraser University Faculty of Early Childhood Education was interested in learning about this model. So do have a classroom and learning module or program set up with the childcare. So the childcare project, as I noted, will be one of the first in Canada to meet, or I'll qualify that by saying try to meet, the Living Building Challenge. The Living Building Challenge requires that the building is energy independent, so essentially a net zero building, water independent, meaning that it is collecting, managing, using, and treating 100% of its annual daily water needs. There's exemptions to that, which I'll get to. Free of toxic materials, which is shockingly hard to do, and completely local in its composition, which means that materials radius, if you're familiar with LEED, gets much, much tighter, where 100% of the materials, again, with some very minor exceptions, have to come with a very small radius, and that poses its own challenges and problems. And then last but not least, certainly a joy for all who live and work in it. And that has been a big success so far in terms of the facility. Staff loving it, long-term retention of staff, and families supporting it. So this is sort of a look at sustainability models that are out there. You know, LEED as a basic model. I mean, I think Canadian Building Code has, you know, more or less with quality developers moved into the LEED world. To do a LEED certified building is, to us at least in BC, and with the national code and with STEP code for energy efficiency, the LEED buildings in an urban environment where you have access to transit and all of those community-based points that you get in LEED, LEED certification is fairly straightforward these days. Gold is still a high quality building, certainly, and a bar above a building code building. And then when you get into platinum, you're getting into, you know, what we would call your truly high performance buildings. And I would circle into that platinum slide also Passive House, although Passive House disregards the efficacy and the sustainability of the materials you're using. At this point in time, it really is an energy model, but it's certainly, as an energy model, it's in that platinum plus level. And then living building, which the childcare is being designed to sort of net zero water, energy, no toxic materials. And then the future beyond living building would be restorative design. So where LEED buildings seek to do better, living buildings seek to have zero impact. And then restorative design would be those buildings that in some way, shape, or form produce more than they need. So more energy than they need, treat more water than they need, for example. So most of you probably know this, but the key to success in any sustainable building is an integrated design process. That process was done with team members throughout the educational community, academic, and development world that was going to be involved with this project. Through a series of workshops. So, you know, first workshop was really involving those people that would be running the childcare and what they need in a childcare facility. The second workshop then brought in the planning department, as well as the Fraser Health Authority and other consultants, noting that we would be really pushing the barriers in terms of building code, really using a lot of performance code rather than prescriptive code. And then finally, and most interestingly, was really bringing in the children that are in the existing childcare facilities at SFU to see what they really wanted to see in a childcare facility and what things were valuable to 3 to 5 year olds. So ultimately, that's the location. As it's a bit of an older aerial photo, that green ring around University Crescent is now almost fully developed with residential towers up to 20 stories in height. And everything below to the south is residential buildings, townhouses, and low-rise condominiums, sort of up to 4 stories in height. So a real diverse mix of housing types in the community, anywhere from 3-bedroom family homes to studio apartments. A real diverse mix. So we centered the university childcare, 1 block off the high street, right next door to our fairly new University Highlands Elementary School, which is a public school. So very walkable, very accessible, right adjacent to Richard Bolton Park. And the lower photo, of course, is the back of house of the childcare facility. A slide coming off the roof, that's that engagement, that play, as well as the ability to move children with physical disabilities or other disabilities up to the mezzanine space via that ramp and still allow them to enjoy the experience of the slide, and a lot of natural play equipment. This was in the early days with a few pieces still not installed. So here's a look at the building itself and the objectives of the building. So as I noted, it's designed for 3 to 5 year olds, but it does include a research and observation room, which you see in the far left side of your screen. Exterior washrooms, really building a building around convenience. And this is what happens when you talk to the people that will be working and running and operating that building is, having indoor washrooms only is a pain in the butt when 70% of the time the children are playing outside. So very simple things that add demands to the building. More washrooms equals more black water, which equals longer piping runs, which equals et cetera, as well as provision of retreated stormwater for your art sinks, for your hand washing, et cetera. Site area is about 2,000 square meters, floor area about 530 square meters or almost 6,000 square feet. And a very comprehensive outdoor play area of about 4,400 square feet. Our construction costs for the project, including landscape, basically a full turnkey operation, fully furnished, operating, ready to go, was $3.2 million. That budget's a really interesting part of this story, in that we looked at 4 equivalent childcare facilities that were being developed in the region at the same time, of varying standards, anywhere from LEED certified to LEED platinum. We looked at construction costs for other similar wood frame structures, and we averaged that price and said, okay, this would be a price for a conventional building. And then our board of directors said, there's no obligation to meet the living building challenge here. It was something that we wanted to explore within a preset budget of $3.2 million, which would have been the standard delivery cost for a LEED certified childcare building. So that was our objective. The only thing not in cost NIC is solar thermal panels at $110,000. Because we're partnered with a utility provider in the community that I spoke about in my previous presentation called Corix Energy, and those solar thermal panels would become part of the buffering system of the neighborhood energy utility, so they would absorb that cost. We were not required to have any parking on site because this is really focused around local community, local staff providers, so all we have is drop-off spaces. So performance of the project, we're looking at an electrical energy intensity of 65 kilowatt hours per meter square per year. So fairly high energy performance, certainly not as high a performance as some of the more modern passive house projects, but remembering we're looking to tie into a low carbon neighborhood energy utility. We looked at our potable water consumption from municipal sources, and it's a surprising number. It's almost 1,200 liters per occupant per year. And so compared to a reference building, we were looking to reduce that potable water need by 80%. That of course lowers your demand on the building systems as well. And then we started tying this thinking and all of these thoughts to the actual living building challenge. So here's the living building challenge on the left-hand side. Right is just an expanded diagram of the building itself from site to roof. Basically, the categories of the living building challenge, like LEED, are site. So, you know, are you doing this, are you selecting the site responsibly? This site was a previously disturbed site that we used for this. It was used for storage and backfill and waste for the initial construction of the campus. Limits to growth is really working within an already planned community with planned density. Habitat exchange is interesting in that you're looking to offset your site footprint with preserved habitat elsewhere. And that can be a very large, what they call scale jumping. You can go way outside of your region. So we could have bought a hunk of land in the Yukon for the same size and dedicated that for permanent habitat exchange. I have some emotional challenges with this, but at the end of the day, up at UniverCity, we had set aside a considerable amount of land comparable to the entire community in terms of permanent conservation area and green space through the development of UniverCity that it qualified to meet the habitat exchange. So our conservation area on the mountain also worked for our habitat exchange. Again, this is that scale jumping for things that you can't do on site. You can maximize opportunities within your local neighborhood if you're already doing sustainable things. Net zero energy was determined to be achievable because it's really just how much stuff can you put on the building that delivers energy. So it's a cost factor, it's not a technology factor. So materials was the really interesting one. The materials red list is a very specific red list of materials that you cannot use in a building because those materials have either no end-of-life disposal methodology, have highly toxic origins or in the creation of fabrication of those materials, or during the use and consumption of those materials continue to be toxic. So it really minimizes the list of materials you can use in a building, which is not necessarily a bad thing. It's just an availability thing and a cost thing. Construction carbon footprint is achievable, so you're really offsetting your construction carbon and tracking that. Responsible industry is finding companies that also adhere to the same values you are and are willing to track and record those materials. That achievable is in red because it is challenging for that level of documentation. The materials radius I'll get to shortly, but very, very challenging in terms of our location on the West Coast, given that a lot of our radius is in the middle of the ocean. And when you look at the centers, the centers of fabrication of construction materials, they're all focused largely in Eastern North America. Construction waste is very achievable. British Columbia and most of Canada is pretty good at providing good construction waste stream management. Water was an interesting one to us, and it's in orange because there are lots of water systems available in the marketplace today, but there's not a lot of systems or a lot of municipalities where these things come together, where a municipality is willing to approve, for example, on-site black water treatment in an urban environment. So while we knew these technologies were achievable, it was that negotiation between municipality, local health authority, and ourselves and the equipment provider to see if A, we could find a system that would work, and B, it would be approvable in the context of young children. Indoor air quality, again, this is really out of the lead books, fairly manageable in terms of 100% fresh air, good quality source control. And then beauty and inspiration, I mean, it's a childcare facility, it's for kids. Bit of a no-brainer for this one. You're building a space for children. It should be wonderful. And so I'll dive a little deeper into some of this here. So the first one's energy. 100% of the building's energy needs supplied by on-site renewable energy on a net annual basis. And I'll speak a little bit about the district energy utility and my challenges with the living building challenge here. So we looked at the total energy load in the building. Heating, of course, in North America or in Canada is the primary load, followed by lighting. Surprisingly, the black water treatment takes quite a bit of energy, and then other minor items. But really, we're dealing with heating, lighting, and the black water treatment facility in terms of, and the black water is mostly all of that pumping energy and treatment energy. So the living building challenge hates combustion. Our neighborhood energy utility within the SFU campus and within the university neighborhood is a bioenergy facility that is combusting waste material. So this is primarily wood and organic waste, largely from the construction energy that is dirty, uncleanable, untreated, and otherwise would be directed to landfill. So rather than directing these materials to landfill, they're directed to our neighborhood energy utility, which combusts this material at close to 92% efficiency with good quality air scrubbing and condensing systems, creating very little local and larger emissions, and is considered throughout Europe as an incredibly highly efficient, highly environmentally friendly energy system. And this is disregarded by the living building people because of the combustion model. So we basically looked at the option of working with Corix to, as I said, buffer the neighborhood energy utility by sticking a bunch of solar thermal on the roof of the building and seeking 100% of our annual energy consumption through that solar thermal, connected to our neighborhood energy utility. So basically we're preheating water into the neighborhood energy utility, net metering, getting a positive result for that, and hopefully producing enough solar energy through that net metering system to be net zero energy. At the end of the day, what we found is solar thermal is a very fickle material, and it delivers energy at peak periods at really high temperatures that a neighborhood scale system that runs on a moderate water temperature system has troubles absorbing. And ultimately, it's taking a lot of jigging to get our building to about 80% net zero energy. So we have yet to achieve the certification of a net zero energy building. We're about 20% shy of that because we're producing it in terms of the math of the solar thermal energy and the metered volume, but our neighborhood energy at the temperature it operates at cannot take it all in at the peak periods it's being produced. So we're basically blowing it off. So a bit unfortunate that way. Had the living building program allowed combustion, we really probably would not have even needed these solar thermal cells, except to maybe offset the missing 8 to 10% efficiency that the system itself is not providing. So anyways, here you get a look at how that solar energy system works that I just described it. So we have the evacuated tube solar collectors on the roof, basically run through a heat exchanger, working with a mechanical room. You know, some of that is captured for the in-floor heating, but the majority of it is brought into the Corix bioenergy system. And then again, we overproduce to offset our BC Hydro power supply, which really electrical energy is only used in this case for lighting and plug load, which is minor in this building. So the next item is water. So according to the Living Building Challenge, 100% of the occupants' water must come from captured precipitation or closed loop water systems. So as we all know, this is really, really challenging. The Fraser Health Authority and the City of Burnaby regulations require the treatment of drinking water with chlorine. Therefore, the project's drinking water is supplied through municipal source. That's an acceptable deviation from the Living Buildings Challenge, with a letter from the Fraser Health Authority and the City of Burnaby saying they would not accept on-site treated water that is only treated through UV filtration. So we do use municipal water for all drinking taps. Rainwater is collected and treated before used for flushing toilets. It's actually also now used for janitorial sinks, and it's used for all of the laundry systems, and it's used for the commercial dishwasher because that essentially boils water prior to cleaning the dishes. And the project has no site irrigation. So this is where we go back to scale jumping. So this is the stormwater question. So certainly in British Columbia and the Lower Mainland, we get a lot of stormwater. So stormwater and building water discharge has to be managed on site and integrated into the building. So we produce or capture more stormwater on this site than we would ever be able to use on an annual basis. Particularly during the wet seasons. In addition, the size of the cistern or storage facility would have to be massively large. So fortunately, at UniverCity, right from the outset, we'd worked with the City of Burnaby to have neighborhood stormwater management. And I spoke to this in my last presentation, where 100% of the community stormwater is not put into a conventional storm system, but is rather managed through swales, infiltration galleries, and ultimately ponds, and then dispersed to the Stony Creek watershed. So we were able to tie all of our residual and excess water out of the cistern into the community system, knowing that it was being treated 100% naturally. So it really was a low cost solution for us that was already managed at the neighborhood scale. The sewage and black water and gray water was treated on site, and I'll speak to that system in a second. So really here's the water cycle scheme. Is the municipal water, as was required by code, was used for really the sink and the drinking fountains. And then, as I noted, actually, we've since been able to migrate the dishwasher, because it's a commercial dishwasher, and the laundry into the rainwater system. So the rainwater in the storage tank, because we had residual water, is now being used for toilet flushing, all the janitorial needs, the laundry, and the dishwasher. Irrigation is a bit of a misnomer. We don't really use it for irrigation. What we do is we reject some of the residual into the underlying soil, which acts as sort of a passive irrigation. We have no water features in the building. Anything that has been used in the building then goes through our water treatment system, which is backed up to the city sewer as required by the code. We have yet to have to utilize or back up to the city system, and it goes into our either our UniverCity communal rainwater stormwater facility or into our black water treatment system. So here's a blown up drawing of really how that works, and it's just that flow diagram put into 3D for you, so fairly straightforward. And so we've worked with a group called EcoFluid. This is our black water and hard gray water treatment system. Don't ask me what USBF means, I forget. And I actually tried to look it up before the presentation, but basically it's a combination anaerobic and aerobic all in one system. So basically all black water is pumped into this facility. It goes through an anaerobic digestion process. Then it's further filtered through a carbonized area. And then finally it goes into an aerobic zone that allows the growth of bacteria that further treats the water. And then at the end of the day, there's basically two tanks that this moves to that you don't see. It's under the blue tarp there. One of the tanks holds the sludge, which is all of the solid material as it breaks down, goes into an organic sludge component that is pumped out once a year, brought to the Annacis Island treatment facility and turned into fertilizer. All of the liquid portion, which is about 80 to 85% of the effluent, is rejected to ground within the childcare site below 1.5 meters in depth. We put in a couple of wells just to make sure there wasn't any fecal chloroform or any other buildup of contaminants. And 5 years in, we're showing nothing that would be contaminated. So that water that is coming out is essentially equivalent to rainwater in terms of its quality. And that's how it's considered by Fraser Health. So it's been a fairly good system. We get it maintained, quote unquote, on once every 3 months. We used to do it once every 2 months, but now we're sort of a quarterly cycle. And really all that is just having someone come in, inspect the facilities, remove any materials that have found its way from kids flushing, napkins, paper towels, or things that are inappropriate to be flushed, and simply removing those. There's a catch basket in there. And that's really all the maintenance is. So it's been a pretty low cost system. So there you go, the influent, the black water comes in, goes through the pumps, the lift stations, through the biology system, back through the UV tank in terms of the liquid for UV disinfection, and then out to the disposal field. So, you know, graphically fairly simple. The technology has proven to be fairly robust for us, knock on wood, 4+ years in. It's actually been, to me, one of the biggest successes because of how easy it is to operate. Just a photo of construction of basically a landscaped, highly infiltrative play area for the children using natural features like cedar stumps as play features. But really what we're showing here is the area below that sand bed is our entire site infiltration gallery. So doubling up on the uses, you need large layers of sand and soft surfacing for children's play. You also need that for absorption and infiltration. So things can work together very well. This is a look at the play features in the facility. So this was an interesting and fun part of the project. So the Living Building Challenge doesn't require you necessarily to meet their requirements in terms of the external space of the building. We did choose to build all of our play structures meeting the Living Building Challenge. using native materials that were found within the community or found within the appropriate materials radius for the Living Building Challenge. So we have a variety of interactive features like stepping stone, using recycled steel rods to create what we call the ropes nest, which allows children to use rope salvage from the local sailing industry to create all kinds of structures and features. And it allows the play facilities to continue to change and evolve over time rather than a static piece of plastic play equipment. Worked with a local artist to salvage willow and rebar and create these woven willow huts that continue to change with seasonality and time. As well. So it's been a really fun and interesting part of the facility. So these are the woven huts. Alistair's sample done on his own compound on Hornby Island is to the right and to the left, using those kinds of ideas to create the structures. This was perhaps one of the biggest things learned from Ledcor, who was the contractor. They were very familiar with LEED, not at all familiar with the Living Building Challenge. And they noted that as with LEED, we realized early on that to be successful, we would need a system that was teachable and repeatable. So it couldn't be new every single time a new trade came on board, every single time a new contractor came on board. They needed replicable, repeatable systems. So they really developed a spreadsheet system and a classroom system that they reviewed on sort of a semi-weekly basis to ensure that everybody was continue to be reminded, and B, put into this simplified system of tracking what they were doing and how they were doing it. So this is the question I was talking about. So materials was a real challenge for our contractors and for our suppliers. You look at where we're located, and the Living Building Challenge really requires, I think it's 80% of your materials to come from that inner ring. And when you're located on the west coast of Canada, and your next nearest real urban center is Seattle, you're really limited to the manufacturing. So this heat map is designed around the materials manufacturing sectors in North America. So these are building materials and where they're manufactured. And you notice a huge amount of yellow in our radius. So establishing those material flows was really, really challenging. If you're in Toronto, or if you're in New York City, or if you're even in Miami, Florida, despite water, you have a lot more opportunity for materials availability. So our list got really small, really, really, really fast. And so what our team did is they really developed a very small palette of materials and said, let's just simplify the heck out of this building. Let's minimize the number of materials. So our building is made out of really 6 core building materials, you know, steel, hardy board, dimensional lumber, drywall, and flooring material. It's a very, very, very simple building to review for meeting this criteria. And then work on the architecture of the building to make it more exciting and color rather than articulation and change of materials and claddings, et cetera, et cetera, et cetera. So what we learned here is that the materials red list was difficult, very, very difficult. At the end of the day, we did achieve it. And that service radius didn't help that either at all. So at the end of the day, we've managed to be awarded the Living Building Challenge certification for all of these items, except for, as I noted, net zero energy. So it's been a fairly successful project. However, there's been a lot of lessons learned. So, you know, at the end of the day, it's the right thing to do. Would I do another living building? Probably not. But we learned a lot through this process, and a lot of this is applied to, for example, our Parcel 21, which is our next project that we're working on. We also learned that the LBC program is a work in progress. Even 5 years later, I consider every LBC project still a pilot project. You have to do this because you really want to, and because you feel there's some value in advancing the thought around green building or demonstrating to other more traditional developers what is possible within a fixed budget. The project team has to be inclusive. You really need to work seamlessly. There's a lot of research, less so now. The Living Building Challenge is helping people with those materials lists, and a lot more companies have come forward providing themselves as pre-certified red list material companies. And it's educational, we keep learning. In terms of the resources, it's more time and resource intensive than usual. So our soft costs were high on this project compared to other projects. Our hard costs, because of our choice to really minimize materials and use a lot of found and repurposed materials were not expensive. We actually saved money on a lot of our material costs, but our soft costs were much higher in terms of the design team and consultant fees. And the market, you know, even 5 years later is far from being ready. It's more ready now, but it's still far from being ready. Positive influence on other projects, design decisions. It does change design culture and how we look at the buildings we've done since then, and as well as our HCMA and all the teams involved. You really need cooperation of the regulatory authorities. It was both challenging and rewarding with the City of Burnaby once their code officials jumped on board and realized, I think what helped is they know we were the owner operator. So we were taking a lot of the liabilities with this building. Would they have allowed this in a strata condo building? Probably not. And it's extremely place and location dependent, right? If you were in an area where you had to manage everything on site, all of your stormwater, all of your energy, that would have driven costs substantially higher, and even the site challenges and conditions would have been very difficult. So at the end of the day, we're very happy with the project. It has not achieved certification. $3.2 million was our budget. $3.27 million was our final total all-in construction cost. So we're very proud of the project, can hang a plaque on the wall, learned a lot from it. And most importantly is 4+ years later, the staff that work and operate the building do genuinely feel and believe that they are working in a healthy building. They're delivering quality childcare. And those children every single day are learning about a more sustainable environment. As a matter of fact, a year after this facility opened, our elementary school, public elementary school opened, which was built to a LEED gold standard and is a BC Hydro Solar demonstration project. And the principal of that school was worried about the children coming from the UniverCity childcare center and that they would be leaving such a leading edge facility and thinking that her building was dumb and disappointing. So that culture of youth and learning, hopefully these kids continue to take this expectation forward. And so that brings me to wrap up the last 15 minutes on our next project, which is what, like I said, we call Parcel 21. So this is a 2-building, low-rise, wood frame, rental apartment building. You can see the renderings here. We're now, the white building you see on the left is now almost closed up with interior starting. And the east building, the black building you see behind, is 2 grade and is now starting its framing process. We're expecting occupancy in August of next year, so that the September intake of students will be able to occupy this building 100% during that year. And then you'll note what we call the pavilion in the center is this small floor plate steel structure separate from the other building envelopes that will become a public facility for the community and for the campus. One of these things is about large high density communities is they're always seeking community space. Universities are seeking community space, graduate students are seeking gathering space where any kind of event can be programmed. So it's a simple open pavilion that will be a gathering space that brings community and the university together, and also protrudes upon the building setback line to really announce its sort of forward-facing publicness. So a very interesting project. So in this project, the objective, and these are just some more images for you, the objective of this project was really to look at high performance building envelope and ultra high energy efficiency. So less concerned about the materials in the water, although of course the building is 100% connected to our stormwater management system. The building will be fixtured to be 40% more efficient than a traditional conventional building. These are our standard green building requirements for the community. But really what we wanted to do was take a look at the passive house standard in a large format multifamily residential building or rental building. So our premise here was, again, much like the Living Building Challenge, was to pursue passive house. This project was actually initially called Pursuing Passive House by the architectural firm. Because again, our board committed to a standard construction budget for this project, but allowed us to vary our design parameters and priorities to focus on the building envelope to meet, to achieve or meet or try to achieve to meet Passive House certification. Which is also really interesting in a neighborhood energy utility connected community, because a neighborhood energy utility connection needs customers in order to make the utility viable. And if you're building all of your buildings to Passive House, your energy draw is so small that your customer load is not viable for the utility. So this really is a one-off, and you know, lessons learned already is that passive, you know, you're really looking at in new build communities, either pursuing good energy efficiency and connection to low carbon neighborhood energy. That's one model. Or you're pursuing traditional utility connections, usually electricity here in BC, and then pursuing an incredibly efficient Passive House style building. And I think at the end of the day, your carbon objectives run about the same. So you can make easier, more traditional buildings for developers at high performance, standard code high performance connected to neighborhood energy that's providing the low carbon input. Or if you're doing infill buildings or you're doing buildings in already constructed communities, looking at building them Passive House, spending your money in the envelope rather than in the energy distribution systems. So again, standard budget. So what's really interesting in this project, and this is the site footprint of the building, and again, building community is always important in all of our projects. So really we have two buildings framing a south-facing central plaza for not only the residents of the building, but those using the pavilion of the building to create a really welcome sense of warmth and opening and gathering, framed or bookended by two rather simple buildings. So the thing about Passive House buildings, of course, is you want to minimize articulation, you want to minimize window wall, and you want to increase your thermal envelope, which is really your insulation and your air tightness of the building. We basically came up with this floor plate as the most efficient floor plate and model for Passive House construction. There's also a simplicity and an elegance in the building of these, so that again, rather than spending a lot of money on articulations and architectural treatments, you can spend your money in the envelope and the insulation of the building, and really focus on the human spaces rather than the building itself. So that was the objective here. What we quickly realized through Passive House modeling is in multi-use residential buildings, Passive House goes to the center of the earth, which means your parkade facility, your underground parking facility also needs to meet Passive House certifications, which has considerable implications on how much you're creating air tightness and insulation around the elevator core, how much all of your below grade footings are also insulated and mounted onto basically styrofoam plates, which are a code challenge and a code issue. So we looked at what it would take to make the below grade space meet the Passive House certification. At the end of the day, those design interventions would have cost just under $200,000 on the total project budget. Then what we did is we backed it out and we had our company model the energy savings to allow and remember, underground space is underground space. There's sort of a static temperature. It doesn't get that cold in BC. So there's not a lot of energy used to heat a passive parkade area. This would be a little different in Alberta. But the total energy gains by spending $200,000 would have been 1.1% increase in energy efficiency on the building. So we effectively abandoned Passive House certification at that point. We couldn't justify the cost for just over 1% energy savings, and really focused from the grade level up to ensure the spaces people are habitating met Passive House certification, met the air tightness, and met the indoor air quality and air exchange standards of Passive House, because that's really about the comfort and livability of the buildings themselves. So this is a bit muddled and busy to look at, but this is a typical floor plate on each of the buildings. And what we really focused on was the opportunity that while the buildings graphically, and I'll show you, don't look like they have a lot of windows, a lot of the priority in buildings, and there's a lot of glass buildings in the Vancouver area. And a lot of those glass walls are quite frankly frustrating for homeowners because you can't furnish against those walls, or you're simply blocking those glazing walls with furnishings. So reducing your window wall ratio to 30 or 34% is not a significant challenge. And when you're building smaller units, these units will all feel like every room has substantial lighting because the windows start at sort of 2.5 feet high and go to the ceiling. So while they're not wide windows, they're tall windows. They allow a lot of light in and they're carefully placed. And then you're minimizing your solar gain as well, which increases comfort, which increases the opportunity that people will likely have their blinds open, not closed, fighting that heat. So it's the quality of the window space that we're looking at, and fully operable and opening windows. The focus here has been to create highly efficient, smaller units. The 55% of the units are 2-bedroom units in very small floor plates. And then the idea is that on every floor near the elevator core, we have these study or community rooms. So not only do we have the pavilion, but knowing there's going to be a lot of children in this building, we have these study rooms. So after 6 or 7 o'clock at night, when one of the parents has to put the children to bed, and one has to be studying for an exam or a dissertation the next day, they can migrate to these study rooms and find a quiet space that's on their floor that they can wear their slippers to, and it essentially becomes their den, their living room. During the day, these spaces in wet, rainy Vancouver can morph into community spaces for the children to play and gather and meet children within their floor. Secondarily, the security model has been very interesting in that we've left the stairwells open and inviting. They're glazed with windows, and we imagine a flow of families and children up and down those stairs to create them comfortable and to feel like community. And then the security points are all at the ground level entries where they need to have that fob control. But within the building, we want this free flow of people to happen in the building. And so at the end of the day, like I said, we're under construction. So far, our construction budget is on track and on time. So I believe we will be able to build this for a conventional construction cost. And like our childcare facility, our soft costs, particularly all of our consultant fees, electrical, mechanical, structural, are all lined up with where their percentage billing should be at this point. But our architectural and coordination fees on the delivery of the building, you know, we're at 60% on our construction and we're at 85% on our billing on our estimated architectural fees. And so we've just had a hard conversation with our team to see how we can continue to perform with less site inspections, less input from the architect to bring their fees down. So that'll be the challenge. I just got a question coming here. How do you deal with noise insulation in wood frame buildings? Wood frame buildings are typically noisier. There's no denying that. I'm not going to make anything up. We've certainly learned, and our designers have learned in Vancouver, lots of wood frame buildings built over the years, that with acoustic drywall, sound separation channel, in this building with children, particularly the floor-to-floor separation, we've done a lot of acoustic channeling. And I'm not a detailed structural engineer here, but we have focused a lot on, you know, offsetting our beams and acoustic insulation within the floors themselves, as well as acoustic channel within the floors and between the units. So, you know, there will be some sound migration, but it's all within the code allowance for sound. And Ursula, who asked the question, you can email me and I can get you the name of our contractor to provide you a more specific answer or a detail if you would like on that. So really, that's my last slide. I think I'm right on time here, 10:55. At the end of the day, you know, above grade, I hope we'll have a passive house project for a zero construction cost premium. And I'm happy to report back on that to anyone next August when we open the building. So thanks very much.
Okay, well, thank you very much, Dale. That was incredibly interesting. I guess you did a really great job explaining everything because we don't seem to have many questions coming in. But if anyone does want to ask Dale any follow-up questions, we have a few minutes. I'm going to share my screen again. And As some of you are return attendees, you'll be well aware that the Biosphere Institute has been working with Dr. Jill Budefeld, a postdoctoral fellow at U of A, and she's helping the Biosphere Institute to analyze the effectiveness of these webinar series. It's difficult to measure learning, and this survey will help us analyze the success of these events. And so I ask all of you, when you close out of the webinar, a survey will pop up. If you could really take 5 minutes out of your day to answer the questions, we would very much appreciate that. As well, if you put your email in at the end of the survey, you'll be in with a chance to win a portable Anchor solar charger, as demonstrated at the bottom of your screen. And finally, next week, we have a really interesting presentation. Think Bright Homes will be diving into the BC Step Code. With working examples, they're going to explain how Step Code compliance doesn't have to be complicated or costly. So I really hope everyone will bring your questions, because we were looking for a lively discussion on this one. Also, don't forget to check out the online trade showcase, and I look forward to seeing everyone next week. We'll keep the webinar open for a few more minutes just in case anyone does have any additional follow-up questions. If not, thank you for coming. We'll see you next week.